Now let us solve few questions based on the factorization and defactorization results. In this question we have to show that sine 40 degrees minus cos 70 degrees is equal to root 3 times cos 80 degrees. Now here we see that all the angles are non-standard, that is we don't know their trigonometric ratios directly. So somehow we have to bring in the standard angles whose values we know. So starting off with LHS, we have sine 40 degrees minus. Now this cos 70 degrees can be definitely written as sine of 20 degrees, isn't it? Because the purpose behind doing this is all we know is the formula for sine minus sine or sine plus sine or cos minus cos or cos plus cos. We don't have a direct formula for sine minus cos. So therefore we have to convert cos into sine. So now here we have the form sine A minus sine B, that is clearly 2 cos first angle plus second angle upon 2 into sine first angle minus second angle upon 2. So this is the factorization result that we are using. So that gives us 2 cos 30 degrees into sine 10 degrees. Let's keep an eye continuously on what is that we have to bring at the end. Okay. Now the moment we see cos 30, it's clear that we know its value, isn't it? So therefore that is nothing but root 3 by 2. You see 2 got cancelled and we got root 3, whichever was required. So that means the remaining term sine 10 has to be equal to cos 80, and we readily see that it is indeed, because sine of 10 is nothing but cos of 80. So therefore sine 10 can be written as cos of 80 degrees. So therefore we get root 3 times cos of 80 degrees as required. That proves the result. Let's go ahead to the next one. Now here we have to show that cos theta plus cos phi upon sin theta minus sin phi is equal to cot of theta plus phi upon 2. So from the pattern it's clear that we have to once again use the factorization result, because the angle on the right hand side gives us a clue, that is this type of angle appears in the factorization formulae only, isn't it? So therefore let's go ahead and apply the factorization formula on the LHS. See, the numerator is cos A plus cos B type, so therefore it is equal to 2 cos sum of the angles upon 2 into cos difference of the angles upon 2 divided by, in case of sine, that is sine plus sine, we have 2 sine theta plus phi by 2 into cos theta minus phi by 2. So cos of theta minus phi by 2 gets cancelled and 2 also gets cancelled, and what remains is cos upon sine of the same angle, which is nothing but cot of that particular angle, which is theta plus phi by 2, which is the right hand side to be proven. So that proves the result. Let's see one more. Now here this is a little bit twisted, because now if you observe the LHS, there are 3 terms in numerator as well as 3 terms in denominator, and on the right side we have a single term, that is tan of 5a. Now looking at the numerator as well as denominator on left side, we see that since there are 3 terms, the dilemma is which 2 to combine, whether it is a and 5a, or whether it is 5a and 9a, or whether it is a and 9a. So here we should be able to do a quick calculation mentally and see what would happen when you combine any 2. Say for example, suppose we think of proceeding the addition of sin A plus sin 5a. So you know that sin A plus sin B type of result gives us a plus b by 2 and a minus b by 2. So when you add and divide by 2, we are going to get 3a as another first angle and minus 2a as another angle. But if you see 3a, 2a does not comply, or it does not fit in well with 9a. That means there is no use of combining sin A and sin 5a. We can't take anything common. So that's really not going to help us, right? So what do we do is we try the other option. Here, if you combine sin A and sin 9A, we'll come to know that a plus 9A is 10A. That divided by 2 gives us 5A. So here clearly you are going to get one term common. So that's the way we decide which terms to combine. Okay. So I rewrite the LHS by writing the terms in a different manner and clubbing them into bracket, that is sin 9A plus sin A, and then I separately write sin 5A. And same happens for cos also, that is in the denominator cos 9A plus cos A I club first, and then I add cos 5A separately. So in the bracketed terms, let us apply the factorization result, that is sin plus sin A, 9A plus A 10A upon 2 is 5A, and 9A minus A is 8A upon 2 is 4A, plus sin 5A as it is, whole divided by denominator cos 9A plus cos A, once again it is 2 cos 5A and cos 4A, plus here we have cos 5A as it is. So if you observe in the numerator, we can take sin 5A common, right? Sin 5A can be taken common. So therefore what remains is 2 times cos 4A plus 1, and in the denominator also we can take cos 5A common. So on taking cos 5A common, what remains in the bracket is, once again we see 2 cos 4A plus 1. So cancelling the common term, what remains is sin 5A upon cos 5A, which is nothing but tan of 5A, which is the required RHS. So that proves the given statement.